everyone, and welcome to the 4:30 p.m. to 5 p.m. session of the 2022 Open Simulator Community Conference. In this session, we're pleased to announce the presentation, Perceptual Hashes for Copyright Protection and Copybot Detection. Our speaker is Kayaker Magic. Kayaker teaches classes every week on using the 3D modeling program Blender to create objects in World. Please check out the website found at conference.opensimulator.org for speaker bios, details of sessions, and the full schedule of events. The session is being live streamed and recorded, so if you have questions or comments during the session, you may send tweets to @OpenSimCC with the hashtag #OSCC22. Welcome everyone, and let's begin the session.
Hello. Hi. I discovered a way of comparing images called perceptual hashes. Well, I didn't discover it. I discovered that there's lots of literature on the subject, and it's a way of comparing two images by generating a fingerprint of each image, and then you can compare the fingerprints later. There's a web page called tineye.com. I don't have anything to do with Tineye, but they've apparently crawled the web and created perceptual hashes of millions of images. And if you give their web page an image, it finds similar images all over the web instantly. It's really incredibly impressive. But some of you may not know what a programmer means when he says hash. A hash is a mathematical algorithm that generates, that takes a large piece of data and it generates a fixed length string of bits, and we call that string a hash. You'll see some examples of that down below. SHA-256 is a popular modern hashing algorithm that's used all over the place, even in OpenSim. And it's called a cryptographic hash because if you take an object and you change one bit in it, you take a picture and you change one black pixel to white in the corner where you would never notice it, the hash will be very different. So here's some hashes on the bottom of the slide of a hash of an image, of a 3D modeling, a Blender file, a hash of a text file that has some code in it. And cryptographic hashes, you can't use them for deciding if two images are similar to each other because it's a design feature of a cryptographic hash that changing one bit will, or one pixel in the image will change the entire hash. And here's an example. I'm not a big fan of JPEG, and if you take a JPEG file and you load it into any program, I used GIMP here, and save it as another JPEG file, the two files are no longer remotely identical, and the hashes, as you see, these two strings are completely different just because I loaded and saved the JPEG file. I'd say this is one reason not to use JPEG. I'm not fond of it. So perceptual hashes is a really hot topic in research right now, and there are some very clever algorithms, but I am writing in PHP because I want to build this into a website, and I have to keep the algorithm simple. So I found some literature that had some fairly simple algorithms that do a pretty good job, and I implemented them myself. And here's the one that I used. It takes an image and it shrinks it down to a standard size, and then it turns it into black and white, and then it does an analysis of where the image changes by scanning it in a fixed order, and checking for where it gets brighter or dimmer and storing a 1 or a 0 bit. So this has the advantage that it's easy to calculate. It has the advantage that if somebody changes the size of an image, it has no effect on the hash. If they change the color, it has no effect on the hash. But it has a disadvantage that if they rotate the image or they flip it, then it won't detect that change to the image. But this finds a lot of similar images, and it's easy to implement. So once you have two hashes where each bit in the hash it has a 1 or a 0, depending on some feature in the image, you can compare them with an algorithm called the Hamming distance. And even MySQL can calculate Hamming distances between numbers. And so that means that MySQL can search huge databases very fast and find similar images. And if you take those two JPEG images that I showed you before that I hashed with SHA-256, if I hash it with this algorithm that based on the articles I read, you can see these two hashes on the bottom of this slide. They look almost identical, but there's one bit of difference. One letter changed from a 7 to a 3. And so if you set some threshold, like find all images that are within 7 bit counts of each other, then you can say those images are similar. So images are nice, but what else can we do with perceptual hashes? I would like to use it on meshes because I create, well, not a lot of meshes, but some, and I build things for Open Simulator, and I worry about them getting copybotted. So is there a way to generate a perceptual hash of a 3D object? All the literature seems to be concentrating on images. So what does a 3D object have that you might be able to generate a perceptual hash from? Well, it has several different images, and hey, I already know how to hash those, so we're in good shape. It has several different mesh prims built into it. I don't bother to hash the system prims like the cube and sphere is part of the system, and I don't need to copyright those. Maybe their locations, but not those prims themselves. And every mesh has a list of vertices, a table of UV map locations, and normals and triangles actually are important. They stitch everything together, or polygons, and a lot of other features that I've decided aren't germane to calculating a hash, because the positions of the vertices are something that's kind of perceptual. So here's the algorithm I came up with, and I'm open to somebody with other suggestions. But what I'm doing with 3D objects is that I started with something kind of similar to what the people were doing with images. I scale the 3D object into a 1 by 1 by 1 cube, for example, and then I chop it up into a bunch of pieces, like 6 by 6 by 6, for example. And then I count how many vertices there are in each one of those little chopped up volumes. And then, like the image, I scan through all of these volumes in the same order every time. And I look at whether the object is getting more complicated, the number of vertices increases, or the number of vertices is decreasing, and I store a 1 or a 0. And then I also choose numbers like 6 by 6 by 6 or other things like that to make my hashes come out to be 256 bits, so that I can use the same algorithm to compare two 3D models against each other. I can use the same code that I use to compare two images against each other once I have a hash. So I am sort of been roped into managing a couple of grids, and so I picked a small grid that has 90,000 items in its database, and I added a table to the database where I went through the whole grid, and I created a perceptual hash for every mesh and texture. And now I can search for objects of my own that I know are in the asset server somewhere. And this doesn't sound very impressive. Of course, when I search for one of my own objects, I get a 0, meaning there's no difference between these. And but I'd like to pat myself on the back, because this is impressive, because the asset server stores mesh as a binary file format made up by Linden Labs. And I'm comparing it against DAE files that I make from Blender, which are text files and have the vertices stored as numerals with decimal points and spaces in between them. And yet the perceptual hashes come out the same. So I pat myself on the back. I must have written the code right. And then I can use it to test other things. One example is the Athena avatar is kind of a contested device. Some grids might want to say that is a copy-botted item, but I can search for Athena's head in this 90,000 item database. And in, very quickly, it will pop up a list of 4 or 5 items that are within a distance of 7 of each other on that perceptual Hamming distance. And why are some of them different? Well, it turns out Athena has several different versions, and so I don't remember the numbers. Version 5 and version 6 of Athena, there have apparently been slight changes to the head, and my algorithm detected that there was a difference between them. So what could you do with this? My first thought is that this could be added to a grid to try and detect copybotted items. For example, if you add that table, as items are added to the asset server, you generate a perceptual hash and store that next to the SHA-256 hash, which is used for deduplication, for preventing storing images multiple times. And then as people upload items, you could have a list of forbidden items that they're not allowed to bring in, things that have been DMCA taken down or that everyone knows are stolen from Second Life. You can detect those being uploaded and you can refuse to upload them. Or you could detect items that in your own asset database that are similar and send an IM to both of those people saying, hey, are you guys uploading the same image, and which of you is really the creator? Or you could, refuse to upload things that don't have the export bit on, for example, if the export bit is ever implemented. So this could be built into you're being scanned. This could be built into OpenSim, or it could be just a bunch of helper tasks running on the grid server. And that's what I've been doing is because I have a web page that's involved. The web page I'm writing PHP, so I'm calling PHP server helper scripts from LSL to submit items to it. And then another example is to create a registration system. And so this would be sort of like a patent office that creators could take their creations to, and they could have them registered. And what it would do is they would say submit to a web page, a DAE file, and a couple of texture maps, and a picture of what it looks like. And it would record the name of the creator, the hash of a bunch of parts of the object, and the date. And then they could, when somebody else says, no, I created that, you could point back to this database and say, this trusted database says I registered it in 2022, so you must be the liar. So you could use this registration system as a way to make your copyright stronger. It's not, a copyright in itself. It's not a patent, although it's kind of fun to build a building that says patent office on the front of it. And this is a grid that I have set up that has these big platform balances. You put an object on it, you click on it, and it looks up all of the mesh and all of the diffuse textures in that build. And it adds them all to the database for you, so you don't have to go to the web page and add them one at a time. But then on the right-hand side of this picture, you can go to the web page and upload a picture of it. And the advantage of this registration system is that it stores the hashes, and except for the descriptive picture, it doesn't store your data. So you're bringing your creations here, and it just calculates the hashes for you, stores them under your name, and then it throws the actual mesh away and promises not to steal your items. And that's an interesting question. Why would anybody trust me to let my code look at their creations? And one reason is that I promise I'm only going to store the hashes, and I'm a creator too. So I want to protect my items. You should imagine that I'm on your side. And then I'm looking at finding a nonprofit that will take over control of the web page and the grid and the GitHub, which has the sources that I'm using to do this. So I'm giving the sources away, hoping that people will include it in their grids, for example. And so I hope that makes me look a little bit more trustworthy, that you can look at my code and see that it's not stealing your stuff. But so I've talked to Selby Evans, and he says that New Media Arts might be willing to take over this. And then people would feel that some nonprofit organization and not some for-profit a merchant like me is in charge of all their data. So what's next? This is a very preliminary system, although you can go and play with it if you like. And there's a lot of things I'd like to do. I'd like to, let's see. I'd like to, as a scripter, I would love to have a way to generate a perceptual hash for a script, but I can't find anything in the literature yet that does that. So maybe I'll have to invent that myself. I'm currently only looking at the diffuse textures, and I'd like to do the normals and the specular. I don't look into the items prim inventory yet, and that I'd like to add. I'd like to write a command that I could, or a program I could hand out for free that runs on Windows and Mac and whatnot, that you could point at a file and it would generate a perceptual hash for you, and then you could compare that against numbers of items of your own or of suspected copybotted items. And I'd like to convert the algorithms into other languages. Oh, and of course, I'd like to hash more different file formats like FBX and GLTF, which are more modern 3D model formats, and KTX, which is a modern image file format that's specifically designed for GPUs. So where do you want to go next? I don't have a booth in Expo Zone 2 because I volunteered a couple of years ago when they ran low to move everything to Expo Zone 4, where I have had a booth there for years now. And there's a web page now, which isn't painted blue, called mvragency.org. And if you go to that web page, it lets you create an account and upload items, and you can link that account to several of your avatars. In my case, since I live on several grids, I wanted to be able to have Kayaker Magic on Kitely and Kayaker Magic on OS Grid both use the same database. And then there's the grid that has the patent office that talks to that web page's database called mvragency.org:8002 is how you log on. You can hypergrid there. And I have the sources for these hash algorithms in PHP. It'd be nice to have it in a more modern language. At this GitHub, you can go look at the code. And I recommend that you play with TinEye. It's really a fun search engine. And here's a couple of references that I can't paste into text into chat here because I had to switch computers and it's on the other computer. So I think that's the end of my talk. How did I do for time?
You did pretty well there, Kayaker. There's a few questions from the audience.
Yeah, I hope you wrote them down.
One asks, is there a charge for registration?
No, I am currently not charging for the MVRA. I never intended to. One day I might like to ask for donations to help keep the server running, but instead I may turn it over to New Media Arts, and then they would fund the server perhaps, or just put it on one of their servers. So I don't think there's ever going to be a charge for this.
Another question is, what if an object is modified in World or in Blender, for instance? And you might want to refer to the rocket engine experiment you and I did.
There's a term that people who write code for this sort of thing, they call it an attack. For example, you take an image, you change it from red to blue. Haha, that's an attack. Well, this image algorithm that I got would think that the red and the blue images are the same because it only looks at the monochrome version of the image. And yes, there are attacks that would cause this to fail, like going into Blender and adding an extra triangle that's way off away from the center of the object would make the hash change. And so I actually I'm working on a different algorithm that instead of using the bounding box to shrink the object, it uses 2 standard deviations instead, and then one outlying point wouldn't disturb the standard deviation enough to change the bounding box so the scaling would still be the same. And of course, rotating an object, my hash for 3D objects would get a very different hash if you rotated it. So there are ways to fool it. Yeah, Owlies is actually the person who suggested that I use the standard deviation instead of the bounding box to generate the scale factor.
Someone says, could you have a score percentage that would compare things?
Well, it does generate a number between 0 and 255. And you could, divide that by 255, multiply by 100, and say this object is 100% different than that object over there.
Lisa asks, how will fair use be handled?
Well, the registration system, The thought is that when somebody registers an item, it does ask you for each image. Do you solemnly swear that you are the creator of this image? And if, for example, plywood shows up as one of the images, you say, no, I didn't make that one. So the idea is that only the images that you actually made yourself, would you be able to register them as part of your creation. And so if you had an image that you bought from someone with the permission to reuse it, you would have to say, no, I didn't make that one. It's not part of my creative component of this creation.
And if I could contribute a bit to this, I was telling Kayaker about the rocket engine experiment we did. I had taken a model of a rocket engine off of some download site for my spaceflight museum work, and it was like 75,000 vertexes, and I vastly simplified it down to, I think, 15 or 17,000 vertexes, and then made different levels of detail models. So the next one was like 8,000, and then 4,000 and 2,000, and I gave those to Kayaker, and he was able to identify that all of those different complexity models were duplicates of the original.
According to my hash algorithm. Yes. Yeah, and on the patent office, I only look at the highest level model when I generate the hash. I ignore the LODs, the smaller and smaller versions of the same image. And it's certainly possible if all you do is decimate the points, the amount of the locations in a reduced size version of the object might still land in the same places. I think you would get a pretty similar hash if you went back to the large model, and then your improved model, you might get a similar score. Now, and it's kind of an interesting point in the law.
I'm going to break in here, only because we need to wrap.
Okay.
You're going to eat into the time with you and Ada. You can't.
I can't get in her way. No.
No. But Mike, I'll let you wrap up.
Oh, sure. Let me pull that up. And so thank you, Kayaker, for an informative and interesting presentation. As a reminder to our audience, you'll want to check out conference.opensimulator.org to see what is coming in the conference schedule. You won't want to miss our next session, which will begin at 5 p.m. in this region and is entitled A New Viewer Character Avatar. We'd like to encourage you to visit the OSCC22 Poster Expo in the OSCC Expo 3 region to find accompanying information on presentations and explore the hypergrid resources in OSCC Expo 2 region, along with sponsor and crowdfunder booths located throughout all of the OSCC Expo regions. Thank you again to our speaker and to the audience.